Now come to the chapter electrostatic potential and capacitance. Let's go to introduction of this chapter. Already we studied about the work done in the first year. Work done formula is scalar product of force and displacement. So that is F into Fs cos theta. So this formula is used for only if F is constant. If force is variable, then we use integration technique, that is F dot ds, that is integration F dot ds. We know, suppose functions are in the multiplication form, then we use integration. Suppose in division form, then we use differentiation. Anyhow, so here we use the integration technique to calculate the work done if force is variable. So what is mean potential energy? Potential energy is nothing but negative work done, negative force into force dot displacement. So that is minus F dot ds. So work is done against the force. Against the force. Work is done against the force, that is minus F dot ds. So here we applied this formula for the charges. So for the charges we have electrostatic force. So potential energy here, the work done against electrostatic force and get stored as potential energy. What is meaning of this one? Suppose I take the charge, positive charge Q1. It has something electrostatic the field around it. Suppose Q2 is here, that is positive charge Q2 is here. Okay, it is also create electrostatic field around it. So here there is no interaction between Q2 is at infinite distance to the Q1. So where is the Q2 for this one? Q2 is at infinite distance to the Q1. Infinite distance to the Q1. For thinking easily, suppose Q2 is here. Q2 is here. So Q2 is infinite distance. I want to bring Q2 into the field of Q1. Q2 is at a distance R. Say the point here, the point is P. Suppose this point is P. Now P is at a distance R. Look here. Where is the initially Q2 outside of the Q1. Now I bring this Q2. So initially Q2 is away. Field of the initially Q2 is at infinite distance. I want to bring this point. So what is happening here? Electrostatic force is acting on the Q2. Is it? While coming towards the Q1, force is increased. We give some work to the system. What is the system here? Q1, Q2 charges. So we will give additional work to the system because it is electrostatic force is along this direction, but Q2 is moving along this direction. Electrostatic force is along this direction, moving is opposite to this one. When it is in opposite direction, definitely we give some work. So here energy is positive to this one because work is added to the system. Work is nothing but, we know that is kinetic energy and potential energy. So here kinetic energy is not a, so here work done is converted into potential energy. Give work, that means it gain potential energy. So look here, work done against electrostatic force and get stored as a potential energy. Okay, suppose there is a negative charge minus q1. I want to q2 bring away from q1. So what is the electrostatic force? q2 attracts towards this side, so electrostatic force is along this direction, but it is moving against the force. So here also we will give some work. సో ఈ సిస్టానికి ఇక్కడ వర్క్ అనేది ఇవ్వాలి, వర్క్ అనేది మనం చేయాలి. సో సిస్టమ్ additionally it gain the work is nothing but energy, but here energy is potential energy, so it here gains the potential energy. సో వర్క్ అనేది దేనిగా కన్వర్ట్ అవుతుంది? ఆ సిస్టానికి పొటెన్షియల్ ఎనర్జీ. సో హియర్ the work done against electrostatic force and get stored as a potential energy. So here potential energy is nothing but negative work done, so that is minus integration f dot ds. Initially it is at infinite and finally it get at a distance r. So this is the potential energy formula. Electric potential. Suppose there is a charge here q, so it create electric field around in this region. Suppose unit positive charge here, unit positive charge, that is a test charge. So initially it is at infinite distance. I want to bring this unit positive charge from this to somewhere at this the point p, which is at a distance r. So final position is r. Here also we doing the work, so this work is called potential. Here force is electrostatic field intensity. We know that already we discussed in the previous class. Force on unit positive charge. Force on unit positive charge is nothing but electrostatic field intensity, that is E. So here potential formula, instead of force we use E dot dr. So infinite to r, so minus E dot dr. Now the question is, derive expression for electrostatic potential due to point charge. So this question is short answer question. One time I think this is asked. Let's discuss this question. So we take here point charge, that is plus q. It creates electrostatic field around it. So I take a unit positive charge, test charge. So this test charge I want to bring from infinite to somewhere point P, which is at a distance r. So I use some work here. Okay, unit positive charge, I want to bring unit positive charge from infinite to this point. That work is called potential. So what is the definition of potential? Potential of a charge at a point is defined as work need to bring unit positive charge from infinite to that point. See here, work need to bring unit positive charge from infinite to that point. So what is the V formula? Potential is denoted by the V. V is equal to against electric field intensity. So E here variable, so we use integration technique. E dot ds, so it is moving from infinite to r. So here V is equal to minus infinite to r. What is E formula? 1 by 4 pi epsilon naught q by r square. See here, this is dr. See here, we choose here r term, so this is dr. Okay, 1 by 4 pi epsilon naught q is constant terms, so bring them before integration, then we get q by 4 pi epsilon naught integration infinite to r 1 by r square dr. So what is the formula for 1 by r square integration 1 by r square dr? We know that formula for integration x power 1 dx, that is equal to x power n plus 1 by n plus 1. Look here. So what we have done here, integration 1 by r square. R square is nothing but r power minus 2 dr. So instead of x, write r instead of n minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1 is nothing but minus 1. So this is minus 1. R power minus 1 is nothing but 1 by r. 1 by minus 1 is nothing but minus. So this is minus 1 by r. So what is the integration r power minus 2 dr? That is minus 1 by r. Integration is nothing but, that is opposite to the differentiation. Process is opposite to the process of differentiation. Suppose differentiation minus 1 by r, then we get r power minus 2. See here, minus q by 4 pi epsilon naught what is 1 by r square? That is minus 1 by r from infinite to r. See, v is equal to minus q by 4 pi epsilon naught. So this is initial, this is the final. So here change, we take always final minus initial. So first we substitute r in this place and substitute infinite in this place. So integration 1 by r square is minus 1 by r. It is coming, so initial is infinite, final is r. V is equal to minus q by 4 pi epsilon naught. See here, substitute final value, that is minus 1 by r. So instead of r, final. What is the final here? R. So r is coming from infinite to r. So here distance is initially final is r. So substitute this displacement final value r minus final minus initial. What is initial here? Infinite. So in place of r, substitute infinite. So here minus of minus plus, but 1 by infinite is 0. So this term become 0. So we get here minus 1 by r. Okay, don't directly write this one, minus 1 by r. Okay, nothing the problem. So minus of minus plus. So v is equal to q by 4 pi epsilon naught 1 by r. Rearrange terms so that we get easily remember this formula as 1 by 4 pi epsilon naught q by r. So this is the potential formula. So what is the potential of point charge at the point P, which is at a distance r, that is 1 by 4 pi epsilon naught q by r. So this is the potential formula. Next question is, derive an expression for electrostatic potential energy of a system of 2 point charges and find its relation with the electric potential of a charge. What is potential energy? Definition: potential energy at a point of 2 charges is work needed to bring one of the charge from infinite to the point of other charge. So what is the meaning of this one? See, what is the meaning of this one? Suppose a charge is here q1 plus q1. So it has electric field around it, another charge q2, positive charge q2. So it is away to the field of this one, so it is at infinite distance. This positive charge bring from infinite to somewhere point P, which is at a distance r of other charge. So here potential energy formula minus integration f dot ds from infinite to r. So work is done against the force. Electrostatic force is along this direction. Electrostatic force is along this direction but moving opposite to this one. So system need to work. So we give some supply work here. That work is converted into potential energy. So that potential energy is here, the formula that is here, this is. So what is the force formula? That is, we know that is 1 by 4 pi epsilon naught q1 q2 by r square. Okay, ds is nothing but dr. 1 by 4 pi epsilon naught q1 q2 are constant terms, so bring before integration, then we get here 1 by r square dr. So from infinite to r minus q1 q2 by 4 pi epsilon naught. What is integration of 1 by r square? That is minus 1 by r. So this is from infinite to r. So here potential energy minus q1 q2 by 4 pi epsilon naught. So what is the final value? R. So this distance final is r. So minus 1 by r. Final minus initial. What is initial value? So this is the distance. Initial is infinite. 1 by infinite is 0. So this term becomes 0. So we get here minus 1 by r. Look here, potential energy is equal to minus of minus plus. So this is q1 q2 by 4 pi epsilon naught into 1 by r. So potential energy is equal to 1 by 4 pi epsilon naught q1 q2 by r. So this is formula for potential energy. Look here, another point is relation with the electric potential of a charge. Suppose q2 is unit positive charge, then potential energy is become potential, that is 1 by 4 pi epsilon naught q1 by r. So potential of charge q1 at that point is, remember, potential of a charge q1 at that point is 1 by 4 pi epsilon naught q1 by r. So I use 1 by 4 pi epsilon naught q1 by r, that is potential. So potential energy is equal to here 1 by 4 epsilon naught q1 by r, that is V into q2. Instead of q2 I use q. Suppose I take the charge q to bring from infinite to that point. Instead of q2 I take the q, then potential energy here, that is equal to formula VQ. So this is relation between potential energy and potential.